Hello, welcome back to Algebra. The title of this lesson is, of course, Distance Formula, Midpoint Formula, Pythagorean Theorem. This is part 3. These problems are just going to ratchet up the complexity. At this point, you already know how to use the equation, so in order to build your skills, we need to kind of go into more complex areas, and that just means making the points a little bit harder to deal with. So as an example of that, I would call these good medium level, maybe even challenge problems. Let's say you have a point like this. What if the point is 1 plus the square root of 5, comma, 2 plus the square root of 3? And let's say another point is 1 minus the square root of 5, comma, negative 2 plus the square root of 3. Now these types of points, they don't look like points you ever typically use in algebra because usually we're talking about, 3 comma 4, negative 1 comma negative 6, or something like this. But here you have, for the x coordinate here, you have 1 plus square root of 5. For the x coordinate here, you have 1 minus square root of 5. Here's 2 plus square root of 3. Here's negative 2 plus square root of 3. So they're weird. But anytime you see a number plus a radical or a number minus a radical, it's just a number, okay? A radical is an irrational, non-repeating decimals. They go on and on forever. But we represent it as a square root of 2 because that's the exact value. When you have 1 plus that, it's just a number. You can plot it on the number line, but you're going to have to truncate the decimal, of course, to do it. But anyway, try not to get too wrapped up in being scared by it and just treat this as an x value, this is a y value, this is an x value, this is a y value. And so going along those lines, we're going to use the distance formula. We want to find the distance between these points. We also want to find the midpoint between these points. So for the distance formula, as always, it's x2 minus x1 quantity squared, y2 minus y1 quantity squared. And we take the square root of the whole thing. All right, now we have to give ourselves some space because these are ugly. So again, same direction. It doesn't matter what direction we go. We're going to, in this case, let's go, it doesn't really matter. Let's go this minus this, and then we'll do this minus this. So the x coordinate here is 1 minus the square root of 5. And you have to be careful here because what you have to do is subtract the x coordinates, but there's minus signs in here, so it's really easy to make an error. This is the x coordinate here minus this one. So to make it clear, we're going to open another parentheses and say we're going to subtract off 1 plus the square root of 5. We're going to surround this in brackets and have that quantity squared because it's x2 minus x1 quantity squared. x2 minus x1 quantity squared. So we're wrapping it in parentheses because you'll see in the next step we're going to have to distribute this negative in. So if we don't put parentheses, we're going to get the wrong answer. It's this quantity minus this quantity squared, so we're going to keep it in parentheses. And then we have, over here, this one will be negative 2 plus square root of 3 minus this one, 2 plus square root of 3. And then same sort of thing. We have to wrap this guy in brackets and square because what we're trying to do is we're trying to subtract these complex numbers from, not complex, these numbers from one another. But because there's negative signs, it gets confusing. So we're going to have a radical around this entire ugly monstrosity. Now, why did we use those parentheses? You're about to find out why, because on the inside, what we have is now we can start to drop the parentheses, but we have to distribute this in. We have 1 minus the square root of 5. This becomes minus 1. This becomes minus the square root of 5. We still have this whole quantity to square, though. We'll do that later. Then we have negative 2 plus the square root of 3. Then this negative goes in as distributing it as negative 2, and then distributed in as negative square root of 3 quantity squared. And so the distance is going to be equal to the square root of this whole monster. Okay? But we're making progress